Thank you. So thanks a lot about the invitation to come here again. So yeah, this may be the least scientific talk because I was asked to talk about in general about so-called Photonics Flagship program and also the Photonics in Finland activity what we have. And my name is Jyrki Saarinen. And yeah, so the very nice thing about what Finland did about about 5 years ago is that they said that okay, we have programs where let's say scientific work is kind of let's say funded, but they said that okay, we should also start having kind of think about the impact of the science. And then the actually 3 ministries, so they launched a program called Flagship program, and the idea is that they can let's say based on the applications they only chose topics, and there was a separate international evaluation committees for the science but also for the impact side. And the impact means, for example, that there's economic growth, which is important, but also that we are solving societal or global problems. And originally 6 topics were chosen, and now we have 10, so because they added 4. But let's say the topics are, for example, artificial intelligence, 6G for the next generation, communication, cancer research, but photonics was one of them. And we are very proud about that. So the program is called Photonics Research and Innovation. So it's a national initiative now that brings together the key actors in photonics in Finland to develop the next generation light-based technologies. And we have 4 partners, and they are the kind of the leading sites where photonics research is done in Finland. Of course, there are many universities where people are focusing on medical imaging or something else, but these are the largest ones. So Tampere University is the coordinator. I'm coming from University of Eastern Finland, and I'm the deputy director of the program, and our responsibility is really about the impact side, so the collaboration with the industry and so on. Aalto University, the largest technical university in Finland from the capital region, and then the VTT National Research Center of Finland. So we are the 4 partners in this program. It's an 8-year program. So we have really funding for 8 years, meaning that typically the funding is 1, 2, 3 years. So here we can really build long-term collaboration, and so it's really a dramatic change. So it started 2019 and it will end 2026. So there's a very nice funding from the Academy of Finland, which is the main academic funding organization in Finland, but then also the host institutions have to commit to the support. So, and we are doing everything from the science to the societal challenges, economic growth, and then also for the new business opportunities. So what is it? So it's a big program. So 4 partners, we have more than 400 staff or scientists. We are collaborating with more than 50 countries, more than 280 institutions. On the left bottom, there are topics that we are studying in those 4 sites. So there's a lot of different kind of things, a lot of let's say publications and so on, and also we are also focusing here on the education, so international Master of Science programs in photonics, Erasmus Mundus programs, and so on. And we are also geographically well spread. So the VTT has the sites in Oulu north, and then also in the capital region, Aalto in the Helsinki capital region, Tampere in the middle, and then University of Eastern Finland. We have 2 sites in Kuopio and Joensuu in the Mid-East, sorry. And the brain covers the entire value chain. So there are professors and research teams which are working on the theories of novel ways to manipulate light. So they are studying the coherence, partial coherence, polarization, femtosecond lasers, very short light pulses, and so on. We have teams which are working on the new materials and structures, for example, graphene, artificial diamond, and so on. And of course, meta 2D materials, metamaterials, and so on for the structures. Then about going one step further is about the advanced components and light sources. So how to use these technology then to make really components. And then again, one step further, how to make system and instrumentation. And the application areas are very broad also. So about the life science, healthcare, ICT, autonomous vehicles and mobile devices, environmental monitoring, AR, VR, XR, or metaverse, and also clean energy. And it's all about the applications, commercialization, also spin-offs and licensing technology to the existing companies. But that's only one part, because also we want to collaborate with the industry to make sure that industry knows about the latest results, what we are doing at the university and the National Research Center of Finland. But also we want to listen the problems, the challenges industry have, and try to then make ideas. We have a very close partnership with Photonics Finland, which I will tell a little bit more. We are organizing these events for Photonics for X seminars. X means, for example, food safety, food manufacturing, energy, pharmacy, healthcare, and so on. So where we put together the let's say the people really from the lighting or food manufacturing, and then our people from the photonics. Then we also want to work with the education, so we are collaborating with the education with the universities. But then one thing is also important is this Photonics Explorer Kit campaign, which is the kind of, let's say, kit for high schools and secondary schools, so that we try to make them excited again about the natural sciences and photonics too, so that we would get more students, because we are suffering from the lack of students like everywhere in the world in the natural sciences and physics and so on. But then also one important thing is also to have an impact to the normal people, and also to the decision makers, stakeholders. So we have events in the International Day of Light in May. We actually have it extended to the full week of program. We have special events for the girls in science. Also, we have a different kind of competition where photonics is playing the role, and also the Suomi Arena is a very good important event where politicians can be. We are lobbying politicians, so it's in a Pori every year, and there we are, let's say, also telling about the nice things what you can actually do with the photonics, and there we are again for a third time this year. So there's a lot of information that you can also follow about us if you want. So we have the brain.fi website, and if you go to the scroll to the bottom of the website, there's a free of charge newsletter that you can subscribe, so you can then learn about what is going on in Finland. So the newsletter is there. We have also the annual reports published after every year. So that's a very nice collection about what we are doing in the scientific way, LinkedIn page, Twitter page, and so on. Then also, what is now becoming more and more important in Finland is that okay, as we have heard and seen today, there's a lot of infrastructure that we need in photonics, and the government of Finland has also the program called Finnish research infrastructures, which are nationally important, and they get special funding. And we were also lucky that in 2021, the photonics infrastructure was accepted to the program, which means that we can have the special access to the special funding. We call it as a Finlight, and there we have 3 partners. So we have all the brain partners except Aalto University, because they have their own national research infrastructure, the Otanano or Micronova. But otherwise, VTT, Tampere, and us are there. Then about the Photonics Finland. So typically, let's say the scientific, the academic societies and industrial clusters are separated if you look about Europe. In Finland, we had also the academic society called Finnish Optical Society, which was established in 1996. But then when let's say a couple of years ago, the Finnish photonics industry got also excited about the photonics, and they wanted to form their own cluster, we decided that no, we don't want to divide the activity in the academic and industrial. So we decided to actually change the Finnish Optical Society. So we changed the rules, we changed the name and so on, and it became Photonics Finland. And there we are now having members, both the companies, so there's more than 100 companies as a members. There are all the research centers and universities at the bottom row where photonics is done in Finland. And then we have also private scientists and students, more than close to 400 private members in the society. And if you look about the companies, so there are small companies, there are startups, there are also foreign companies who want to follow and learn more about what is happening in Finland, or they consider Finland as a market for them. And the website is easy to remember, photonics.fi. In the board, we have a mixture of both academic and industrial people, about half-half. Every second year, we change the chairman of the society, so that every second year it's industry, from the second year it's from the academy. So we try to, let's say, keep both parties active. So if you look about the key competencies in Finland, this is what we have kind of internally decided, where we have a strong competence. So one thing is optical sensing and also imaging. Imaging because of the Nokia heritage, because you know that Nokia was one of the first companies in the world to bring mobile cameras into the mobile phone. And after that, it became part of the Microsoft. And then when Microsoft withdrew from the market, now there are maybe 20 different companies which are now making the R&D and camera development in Finland, actually mainly in the Tampere region. Then the micro and nanophotonics, so especially the manufacturing side. So for example, in the Joensuu region, we have had electron beam writing system already from the 1997. So a lot of experience about how to manufacture small features. Also about the roll-to-roll manufacturing, 3D printed optics, that's what I'm doing. MOEM, silicon photonics, VR, AR optics, and so on. So for example, the HoloLens display, which is based on the very nice waveguide, that's fully developed and manufactured in Finland. So there are about close to 200 people in Helsinki, in Espoo actually, where these displays are manufactured. Then laser and fiber optics. So Tampere region is very, very famous for these. There are many startups. Actually, on just Tuesday, I was there again. 3 companies opened their laser factory in Tampere. And then nowadays, XR, VR, AR, MR, however you call it, Varjo is making the most accurate, highest resolution VR headsets. Display is one of the competitors for Microsoft, but Microsoft have their activity too, and so on. If you look about the photonics in Finland, so as you know, it's difficult to get any figures because the photonics is not where you can get easily any figures and so on. So you have to really collect. So we have had this kind of inquiry twice, and actually just now we are collecting again new figures which will be published end of May. So we have about 200 maybe today, because this is officially from 2020. So mainly we have close to 300 companies already in photonics. And that's the highest number of companies per capita in whole Europe. So we have more companies in photonics than Germany, UK, Netherlands, and so on. And then, okay, it's about a 1.2 by 1.5 billion euro revenue and about close to 5,000 experts in photonics. But what is even more important here is if you look about the growth. And that was kind of, let's say, confirmed because we made this 2016 first time. So 2020, we were able to kind of check that because already 2016, the companies told us about very high growth in the number of, in the revenue, number of employees and so on. But 2020, we were able to confirm that these are really true. So the business is growing very fast now in Finland, more than average in globally. The business is very well spread. So most of the photonics companies in Finland are manufacturing systems, instruments, and components. So over 60% of the companies. Then of course there are distributor services, and then some raw materials. Also, let's say if you look up at the markets, they are very well spread. In 2016, we were missing the information and communication, but now it's back because we have a lot of activity. Also, the Silicon Photonics, Rockley Photonics, which is one of the leading companies there, has their site in Finland. So very well spread apart if you look about what kind of markets and applications we are doing. Then also what we are doing in the Photonics Finland is also that we want to give the maximum visibility for the tiny Finnish companies in the biggest exhibitions. So every year in SPIs, in the Photonics West, we have a Finnish pavilion where we can bring all the companies together. And this is the set of all the small companies which were in this Finnish pavilion this year. We have the same thing then about a big event. Welcome there if you want. So we have every year the Photonics Optics and Photonics Days in Finland, where we are really bringing together both the academia and industry. So we have a separate program committees for designing the program, and we have a parallel sessions. So we have the industrial track, and then we have the academic track. And we last year we had this event in Tampere. We had 350 people, about half from industry, half from the academia, and also about, let's say, over 50 students there. And then we have also a lot of kind of side events. We have a networking dinner, welcome reception, job fair, student meetings, Nordic Photonics meeting. Flagship has their own event also, Photonics Finland annual meeting, Women in Photonics events, and so on. And then, of course, it's a normal academic event where we have the students and the scientists have sent their abstracts, and they are giving their oral talks or then the poster sessions. In the industrial sessions, we always decide a special theme. And this year it will be the spectral and hyperspectral imaging. It's about nano and microphotonics. But then especially because you know that Finland just joined the NATO, and that topic is really kind of, let's say, important now because we know what is going on in Europe. So the photonics in security and defense, we have 8 invited industrial speakers talking about those topics. What kind of role photonics is playing in that field. The event will be a 3-day event in Joensuu, Finland. So welcome.
It's your university.
Yes, my university, yes. And we are expecting, let's say, we already have 33 companies. So we have also exhibition, and we have already 33 companies registered to the exhibition. And yeah. And then, okay, the next kind of event will be after that will be then the laser World of Photonics in Munich, where again we will have our Finnish pavilion, where we are again bringing companies together under one let's say a booth or the larger booth. And then let's say the last thing is maybe about the education. So that's very important. We have 2 international Master of Science programs in Finland, one in our university, which started already 2010, and then the newer one, which is about 3 years old, in the Tampere University. But then also a very important thing is these Erasmus Mundus programs, because there the students get a full scholarship from the European Commission, and we have actually 4 of them in Finland. So 3 of them are in our university. So the computational color and spectral imaging, then there's this imaging and light in extended reality, which is a very special program because that's the program together with Europe and Japan. So half of the students are from Japan and half of them are from elsewhere. And then also these photonics for security, reliability, and safety. And then the big one, which is Europhotonics. Then of course we have the doctoral programs. And also one big thing what is happening now is that starting this autumn, the photonics will be not anymore under kind of, let's say, natural sciences, but it belongs to the engineering degrees. So that again, of course, mainly it's about the same thing. We have the same courses and so on. But besides that, we are also giving certain key education or key courses which we know that the industry needs and wants. So we will move all this photonics education in our university under the engineering education. Just briefly about my university. So we are the largest photonics site in Finland, and we have organized all the photonics activity under this Center for Photonic Sciences. It's a kind of virtual society center, so we don't have any own funding and so on. Formerly, last year, it was still known as Institute of Photonics. The key thing is that we have photonics is a multidisciplinary. So we have people from the Department of Physics and Mathematics, where I'm coming from. My background is in physics, but we have also professors from the School of Computing, because you know that the photonics is a lot about the data, handling the data. Then also the chemistry, so photonics materials, Department of Environmental and Biological Sciences, Biophotonics, and also the Department of Applied Physics, where we have optical medical optics. We have about 25 professors and their research teams, and about 60 Master of Science students besides that. So it's really a big, let's say, activity. We have a very nice laboratories with the clean rooms, research equipment worth more than 10 million euro and so on. And the main research, what we are doing, covering our university, is all the way from the optical sensing and imaging components, their precision manufacturing, and then the theoretical part, coherence and polarization optics, optics materials, and then the new thing is also quantum photonics. And then the last slide, that again, let's say one of the consequences from this brain flagship is that we want to build even closer collaboration with the industry. And that's why we launched this Photonics Center last year. So actually, this is the picture of our campus. So actually, in the central part, that's where our photonics activities, the clean rooms and everything. Now one part, so this 3-story building or wing of that building is actually for companies. So we let the companies to come to the campus, so that they can have their offices there, they can have their labs there. And why there? Because they want to have a close interaction and access to our facilities. So they can rent and use our clean rooms, our equipment for optical metrology, for manufacturing and so on. And of course, they are recruiting our students. So we are kind of, let's say, saying that there's a tunnel now that they are kind of absorbing all these students when they get graduated so they get nice students into their companies. So we are offering expertise. Of course, we are having collaboration with those companies, but we also offering them special education. Then, like I said, that we can either rent them space, or we can even let them to use the equipment so that we are using them, so services. And then, of course, they can get access to the facilities. When we started last year, we are already 100% full, so we cannot get any more companies there. So actually now we are negotiating with the university to get extension to the Photonics Center. So that's briefly about, let's say, what we are doing in Finland, what is happening there. So thank you very much.
Thank you very much. Being the privilege as a chair, I would ask one question to you. Finland, Finnish nation is the happiest nation in the world because they succeeded so much in photonics, or vice versa. You are happiest nation in the world, decided the photonics fits much more.
That's a good point, because we don't believe, we believe that there's something wrong with that study. Research.
Okay, thank you. I hope we can share a lot of expertise.